Good morning everyone. My name is Munesh. I am from Triple department. Today my topic is that the FR is equal to F for R, where R is equal to xi plus yj plus zk. Introduction to vector calculations. Vector calculations is a branch of mathematics considered with vector fields and differential operators. Has applications physics, engineering, and computer science. Understanding vector fields for studying field dynamics, electromagnetism, and more. Next one. Gradient operator delta. The gradient operator denoted as delta measures how a scalar field changes in space. Produces a vector field pointing in the direction of the greatest rate of increase of the scalar field. The gradient is defined Cartesian coordinates as df delta f is equal to dou f by dou xi plus dou f by dou yj plus dou f by dou zk. Delta f is equal to grand f. Delta f is equal to delta f by dou x by dou xi plus dou f by dou yj dou f by dou k. Next. Scalar field f of r. A scalar field assigns a single value of every point in space represented as fr. In this context, r is a position vector defined as r is equal to xi plus yj plus zk. Scalar field can represent physical quantities like temperature, pressure, or potential energy. Position vector. The position vector describes the location of a point in three-dimensional space. It is experienced as r is equal to xi plus yj plus zk, where xy and z are the coordinates. The magnitude of r is given by modulus r is equal to root h square plus y square plus z square. Chain rule in the vector calculations. The chain rule is fundamental concept is calculation for differentiating composite functions. In vector calculus, it is always used to differentiate functions that depend on the other functions. Applying the chain rule is essential when finding the gradient of fr. Calculating the delta of fr of r. Calculate the delta f of r. We are applying the gradient operator to the scalar field f of r. This involves taking partial differential of f of with respect to xy and z. The result is a vector that describes the rate of change of f, the direction of r. Applying the chain rule. Using the chain rule, we express the gradient as delta f of r is equal to dou f by dou r delta r. Here delta r is the gradient of the position vector r. This gradient for r can be shown to be equal to unit vector is the direct r. H is equal to f of r is just one. Unit vector is direction of r. The unit vector is the direction of r defined as r by modulus r. This unit vector indicates the direction of the vector r without considering its magnitude. It plays a crucial role in expressing gradients in terms of direction. Result of gradient calculations. Therefore, we can express delta f of r as f of delta r. Since delta r is equal to modulus r, we can abbreviate this as delta f of r is equal to f of r. This shows that the gradient of the scalar field is proportional to f of r and the direction of r. Final expression. The final expression of the gradient can be summarized as delta f of r. This indicates that the Gradient of the scalar field f of r is the scalar multiplier of the vector r. That is combines the nature of the scalar field and its spatial as representation. Determines whether or not the vector function is the greatest delta f x comma y of a function. Everywhere define it if so find all the functions with that gradient. Square plus 3y square I plus 2xy plus e power x into j a 1 by 3 h cube plus 3xy square plus c b comma xy square plus y z power x plus a c. Next one, physical interpretation. This result delta fr is equal to f of as a significant physical implications. The struggles that the change in the scalar field is directed along the position vector or this can be crucial field like physical where force field are expressed in similar forms. Example applications, the relationship can be applied in gravitational fields or electric potential in simplified calculation involving forces that depend on the distance from the point source. Understanding the concepts aids in visualizing and solving complex physical problems. Summary of key points. We explored the candidate operator and its applications is scalar fields in vector calculations. The demonstrated and the that f of r can be expressed as f of r through the chain rule. The implications of the result are essential for understanding various physical phenomena. Calculations. The relationship for releasing in connection between scalar field and vector field. Mastery of this concept is crucial for advanced studies, mathematics and physics. Continuous exploration of calculations will be defined your understanding of special phenomena. Reference vector calculation is Beryl, Mason and Mandana Dharma. Calculations manufactured by makers of his online research such as Khan, academic and amateur operator fields for operational expression and examples. Feel free to adjust the content necessary for our specific needs. Thank you.